Welcome. In today's presentation, we're going to dive into the topic of science education today with a specific focus on the next generation science standards and the Pennsylvania Science, Technology, Engineering, Environmental Literacy, and Sustainability academic standards. The goal of this presentation is to help you develop a foundational understanding of both NGSS and the PA Steel standards. And then later in the module, we're going to provide you with access to tools to assess your current curricula against these new academic standards, and then finally ask you to evaluate your own teaching to identify alignment opportunities. The agenda for this presentation is we're going to start with a history of the PA Steel standards. We're going to dive into the idea of 3D teaching and learning. Then we're going to get to the nuts and bolts on how to read the new PA Steel standards. And then finally, I'm going to let you go and give you time to evaluate your own instruction based on these new standards. Before we begin, I want you to just take a moment to self-identify and self-reflect on your own prior knowledge of the PA Steel standards. Would you consider yourself at a level 1 where you are totally lost in that PA Steel's vortex? Do you see yourself maybe at a level 3 where you're still exploring your PA Steel's journey? Or are you that level 5 Steel superstar? Where would you assess your own prior knowledge? When we think about the new standards, I think the first question we have to ask is, why did we need new science standards? It seems like the one constant in education is that things are always changing. Well, let me give you a few ideas. The first one, when we look at our previous Pennsylvania science standards, it really was an outdated framework. Our previous standards before PA Steels were from 2002, nearly a quarter of a century ago. We also know that our new standards, whether it be NGSS or PA Steels, really need to align to current best practice in science education. And in these new standards, we really want our students to go beyond memorization, and we're focusing now on scientific practices and deeper understanding of science content. The new standards also provide higher expectation. We need to support sophisticated reasoning even for young learners. As we move away from memorization, we really are diving into giving students the opportunity to engage in critical thinking, to use data to make informed decisions, and to look at science through a phenomenon lens. And then finally, our new Pennsylvania standards also add a new environmental focus that is missing from the national standards. So we're going to talk a little bit more about the environmental literacy and sustainability, the EL&S of our PA Steels, and how it applies to science education in Pennsylvania. So let's look at our path to get to the PA Steels. And we're going to go all the way back to the end of World War II. So after World War II, science education, or we can say science education throughout U.S. history, has always been a topic, a subject that was meeting a national need. So you think about reading, students need to read because that's how they access information. Math, we want students to be mathematically literate. Science education, really our focus has always been on meeting a national need. And if we think of post-World War II, the national need, this was when we were in the Cold War. And the idea in that time was we needed to identify the talented, scientifically and mathematically talented students so that they could pursue high-level science education and careers because it was essential to our national safety. Thinking coming out of the Manhattan Project, we're now in the Cold War. We think of Sputnik, the Russian satellite, the race for space. So much was happening in that time where we really wanted to, in essence, identify those students who could really lead the nation forward in science. One of the problems between 58 and 80 was It really wasn't science for all. It was science for those who we deemed to be capable. So there was a big transition between the 90s and 2009 where we were really looking at the idea of science for all. You'd heard some words like the gathering storm. Like we identified an issue where we now needed a scientifically literate population. We needed everyone to join in this pursuit of science. It was essential to um, our national needs. So at that time, we had some seminal documents, one being How People Learn, which we will explore in another module in this course. We have the benchmarks for science literacy. We have the Atlas project, but we've really started diving into how students learn science and how we can create a science curriculum that will meet the needs of not just the select, but all students. Taking the work that happened in those 2 decades, in 2011 was a time where we came together, many states came together, and there was a national push to create what we call now a framework for K-12 science education. We came together and decided as a collective, what should students know, be able to do, and what should be the focus of science education for the nation? And out of that very important work, it was called For States by States, bringing states together. We came up with in 2013 the Next Generation Science Standards. It really does change how we teach science. It's based on educational research, it's based on national need, and the goal is that we have a scientifically literate population. NGSS has been around, as I said, since 2013, and it wasn't until 2022 that Pennsylvania began to work on our science, technology, engineering, environmental literacy, and sustainability standards, the PA Steels. So in many ways, we were indeed late to the game on this new change. So we look at NGSS, or the Next Generation Science Adoption across the US. It started, as I said, with a group of states in 2011, and the states are highlighted in blue that came together to work on this framework for science education. From those states, more states began to adopt their own standards. Some of them adopted NGSS just as it is, and other states began to adopt standards that really were built on the framework. Were primarily NGSS, usually with a local twist to it. Now, as you look at this map, you can see that most of the state is either blue or gold, except for a few holdouts that are still in that light blue, that gray color, and Pennsylvania being one of those. And it wasn't until Pennsylvania finally was some would say the 47th, others would say the 48th state to adopt standards that are based on or fully adopted of NGSS. As of today in 2025, we only have one state, that being Florida, who is not aligned now with the NGSS Next Generation Science Standards. Now we look at Pennsylvania. We said that we are aligned with NGSS with a twist. And being nearly a decade late in this adoption, Pennsylvania did have the ability to kind of look at what has been happening with the other states, and we were able to make our standards, we would say, even a step better. So Pennsylvania STEEL standards are very closely aligned with Next Generation Science Standards. We nearly mirror NGSS core concepts, but ours has one primary difference in that we've added another domain, that being environmental literacy and sustainability. So in the original Next Generation Science Standards, what many states reported was that while our goal was to integrate environmental literacy and sustainability within NGSS, they were noticing that it was not, it was a missing link. So in Pennsylvania, we were able to, since we were just now starting with our new standards, be able to address that and add it right at the beginning. Now you think about it. NGSS was adopted in 2013. Our new PA Steel standards are actually not going to be adopted until the fall of 2025. So we're looking at well over a decade late to the game. But here I'm going to give you some positive. There's some positives to being late to the game when it comes to curricular reform. And the real benefit for us is that there is a lot of curriculum out there that is aligned to NGSS and by extraction to PA steels. I just put up a few on the slide here. We have everything from NOAA, the National Oceanic and Atmospheric Association. NSTA is a wonderful resource. Open SciEd, PBS, and the list goes on and on. Again, we have more than a decade of resources out there. Now, I've also put up here if you want to scan it on your phone, or there's also a link on D2L. I have an entire curriculum library. These are not Pinterest. These are not Teacher Paid Teacher. These are national curriculum databases that have been vetted. Most of them are funded from federal grants. But everything from PhET interactive simulations, we have the Exploratorium, which is has some wonderful resources. It's a museum in San Francisco. We have NOAA resources. Engineering is Elementary, which came out of an NSF grant. NASA, the Bay Backpack. The list is extensive of places that you can go to find NGSS and PA Steel aligned curriculum that is high quality materials that you can use. Now, you talk about these new standards. Well, the question is, how will science teaching and learning change as we enter into this NGSS and PA Steel's era of science teaching and learning? Well, it's going to be a pretty fundamental change. Think about it. We're going away from that idea of science for the talented to science for all. And what does that look like? Using best practices, the idea to help us create a scientifically literate, and what do we mean by literate, population? So it's going to be a lot less of teachers providing information and much more of students working in groups to explore scientific phenomenon. Teachers will be posing questions that don't have just one right answer. It isn't what is metaphase in the cell cycle, but rather what happens if a mechanism of the cell cycle malfunctions. So we're asking these more open-ended questions that focus on students using evidence to generate claim. A lot of you've probably heard of claim evidence and reasoning. We're also going to have a lot less of students reading textbooks and answering questions, and a lot more of using multiple sources of information to develop summaries to make those claim evidence reasonings. We're going to move away from learning facts that are disconnected, and we're really going to be anchoring our instruction in the exploration of scientific phenomenon. Students will be posed at the beginning of a unit with a phenomenon, a question that they're exploring. That also means there's going to be less content covered, but the content we do cover is at a much greater depth and complexity. And that, I think, is going to be one of the biggest struggles we have as we change to these new standards, is leaving behind some of those topics that we may feel are so essential. But our goal is that students have a deeper understanding rather than just a broad base of, in essence, factual knowledge. We're also moving away from the idea that teachers are explaining the content before students explore, and really flipping that paradigm where we're going to allow students to explore a scientific phenomenon, to get excited about it, and to use that as a jumping off point to begin some of that explanation. So flipping, instead of explain, explore, we really want students to explore before we get into that explanation stage. Really moving away from worksheets and having students create diverse artifacts, whether it's posters, multimedia, explanations, projects, moving away from those paper, pencil, just tests. Now we look at the PA Science standards. If we compare them from 2022 to our new standards. In 2022, I would say probably 80% of it was all about facts about science, and maybe 20% was students doing science. Often it was confirmation experiments, but a lot more was reading, understanding, and learning about science content rather than the scientific processes that underlie it. When we look at the next generation science standards, also for us would be PA Steele's, we're really looking at a three-dimensional learning where the science and engineering practices, the doing of science, is at equal level with the facts of science, which we call the disciplinary core ideas, and at equal level with something we call the cross-cutting concepts, which is how scientists think. And so that's where I want to dive into it. What is this three-dimensional learning that really is the backbone of the new standards? When we look at the diagram, I like the one over at the right. So if we look at the orange in the center, it's those domains of content that we're used to seeing, whether it's life science or physical science, engineering and technology, earth and space. And then around that is how we do science. And scientists are always asking questions, defining problems, conducting investigations, arguing from evidence. It's that doing. You know, we used to call that scientific practices. Many of you probably have heard the word inquiry. We've kind of moved away from the idea or the term inquiry, and now we call it science and engineering practices. And the reason for that shift is that inquiry had become so overused. We called everything inquiry that many would argue that it lost its meaning. So with the new science and engineering practices, there are 8 of them. It's now where we articulate, what do we mean by inquiry? What do we mean by science and engineering practices? What are those practices? And then finally, on the outer side of this circle is so important because it's how scientists think. No matter what topic, whether it's life science or physical science or engineering and technology, scientists are always looking for patterns. They're looking at cause and effect. Does the shape of this, how does that impact the effect? Energy and matter. There are some ideas and concepts in science that really go beyond the discipline, go in every discipline, whether it's looking at stability and change, scale and proportionality. So we call those cross-cutting concepts. So when we look at 3D teaching and learning, we have our disciplinary core ideas. And if you notice, there's one in the orange here. What is different about our PA Steels is that if we were to look here, is that we've added a whole nother domain in that center of environmental literacy and sustainability. So this is only in the PA Steels. So we have our disciplinary core ideas, how we do science, our 8 science and engineering practices, and very importantly, how scientists think, those cross-cutting concepts. And each of those 3 pieces are of equal importance in our new standards, and that means in our new way of teaching science. So let's begin. Let's talk about a little more about these cross-cutting concepts. And I'll be really honest, when I was learning about NGSS about a decade ago, I will say cross-cutting concepts was the most difficult concept for me to really grasp. And it wasn't until I really looked at the phenomenon in science that it began to make sense to me. So in the next slide, if we look, when we're looking at the cross-cutting concepts and the upper left-hand side, you know, in nature, we can see pattern. We can see how the structure of the honeycomb here really impacts its function. That's another cross-cutting concept. Looking at patterns, even the patterns we can notice, even in the eye of the fly, we know that patterns is one of those cross-cutting concepts. We look at structure and function. We can look at the structure of the bridge and think about its function. We can also see reoccurring patterns here. We can look at the scale. So those cross-cutting concepts are present whether we're looking at a honeycomb or a molecular model. We can see here, right here, we've got a benzene ring, a benzene ring. We can see a lot of those patterns. I know about the structure of double bonds. So regardless of the domain, those cross-cutting concepts are important in how we make sense of the phenomenon that we're seeing. So here's a few more examples that we have. We have everything from pattern to looking at patterns and data. We have structure and function. We have stability and change. So with those cross-cutting concepts, again, it's a way for us to make sense of phenomenon. In the natural and physical world, it's a way of thinking. We can take those cross-cutting concepts and kind of put them into three buckets. One is where we're looking at patterns. Another one is where we're looking at causality, structure, function, cause and effect. And the last one is where we're looking at systems. So whether it's biological systems, chemical systems, we're looking at the systems and making models of these systems, whether it's the water cycle, stability and change. We're looking at energy in, energy out, energy and matter, scale, proportionality and quantity, whether we're looking at the nanoscale or we're looking at the entire solar system. Those cross-cutting concepts, again, can also be seen in how we make sense of what we're looking at, the phenomenon. It can be in the models that we create as we get into those practices. So the next one we want to look at is, we talked about cross-cutting concepts. So now we're going to dive into that science and engineering practices, the doing of science. And it's really had an evolution in the terms that we use. Some of you who are older as I am may remember the scientific method. We called it the scientific method, but one of the pitfalls of that is that students too often thought, and teachers alike, that we had to do it in an exact order and that it was a rigid design where really science was only a controlled experiment. So we said, oh, that's not good. So then we came up with the term inquiry, which started out, as I said, great. We're talking about inquiry in science, which let us know that, it isn't always one step down to the next step, ask a question, but it's a much more fluid process. But again, I said, we really just started using inquiry for everything. And when you overuse a term, it really loses its meaning. So now we're using an NGSS and PA Steels. We call it the Science and Engineering Practices. Again, analogous to the scientific method or inquiry, but we articulate what are those practices. And as you look, you can see a lot of that similarity to the scientific method or inquiry. It's about asking questions, planning and conducting investigations, developing and communicating explanations and solutions. So as you just take a moment to look at these science and engineering practices, I think we all can agree that that is really at the basis of how we do science. So if we look at some of the investigations here, we have them doing building a water filter here, incubating eggs, doing an outdoor field experiment where they're looking for a macroinvertebrate here, really engaging students in the doing of science. Now, when we look at the PA Steels, one thing we notice is that these standards, which are now, they were formally adopted in 2023 with an implementation date of fall of 2025. The big change in our PA Steels as it relates to NGSS is that we have, you'll hear it often said, we've added a fifth domain. So in addition to life science, physical science, earth and space, and engineering and technology, PA Steels has an environmental literacy and sustainability domain. We keep all of the same science and engineering practices and the cross-cutting concepts just by adding that additional domain. So you'll notice when you look at the PA Steels, we'll have the traditional NGSS 4 domains with a Pennsylvania focus with a beautiful keystone there of environmental literacy and sustainability. When we look just a little deeper at environmental sustainability, literacy and sustainability, we really want students to have environmental literacy skills. We're going to be looking at sustainability and stewardship, being a good steward of our earth. And we also have a large piece on agriculture and environmental systems and resources, how we are using our resources for education for sustainable development. Now, if you need to take a pause for a moment, that is perfectly fine. In the second part of this video, we are going to dive into the PA steels.